So we'll do some centripetal force calculations. Okay, we have a fly of mass 2 grams is sunning itself on a turntable. They're 4 centimeters from the center. When the turntable is turned on and rotates at 45 revolutions per minute, or 45 rotations per minute, calculate the centripetal force needed to keep the fly from slipping. So it's that kind of situation. We've identified there already that it's the friction is responsible for exerting the force that allows the fly to move in a circle, because the friction is directed towards the center of the circle. I suppose what stands out here is the 45 revs per minute, or 45 rotations per minute. So I use a ratio method to work out the periodic time for that. And what it is if it's 45 rotations in 60 seconds, one rotation takes 60 divided by 45 seconds. And that 60 over 45 then is the periodic time, because it's a time for one rotation, 1.33. Now we're looking for the centripetal force. We're given the mass, so let's have a look. If we use F is equal to mv squared over r, you see as well there that the slash was in the wrong position. Then what we can do is we can take out the v squared, and if we were to use v is equal to rw, but also w is equal to theta over t. Now for one full revolution, the t there would be the periodic time, so that would be capital T, and the theta would be 2 pi radians. So when you take w is equal to 2 pi over big T, sub it into v is equal to rw, and then sub v squared into F is equal to mv squared over r, you get the formula 4m pi squared r over T. Let's fill it in. And we get 0.002 newtons. Let's do another one. Okay, we've got a car driving around a curve of that radius, maintains a speed of 20 kilometers an hour. We'll have to convert that to meters per second. What is the force of friction between the tires and the road? So it's that situation there where the force of friction will be the centripetal force. That will be our mv squared over r. And we have all three quantities there, they just have to be in SI units. So that's what we're going to start with. The centripetal force will be the friction force, and then later on we'll leave the value that we calculated for the centripetal force equal to mu r. So F is equal to mu r we'll use to get the coefficient of static friction, or the coefficient of friction. So like I said, mv squared over r in SI units gives you 1481 newtons. And if you look at the leftmost portion there, little fs is the coefficient of static friction. That would be mu for us, and that's equal to the centripetal force, capital F subscript c. So now what we need to do is use F is equal to mu r. R is the reaction, and if the object stays on a horizontal level, the force down will equal the force up. So mg will equal r. And if you look at the left hand portion of that latest box, what we have there is the friction force is equal to mu r, and r is equal to mg. So you do a bit of rearranging, fill in your values, and you get 0.13. Okay, third example. So we have an automobile going around the corner, radius r, speed v. In terms of r and v and any other required physical constants, what's the minimum coefficient of friction required for the turn? It is identical to the previous one. Friction is the centripetal force, so that's mv squared over r. And then that F is equal to mu by r. And then r, the reaction, is equal to the weight of the object, because the object isn't rising up or down. So that's F is equal to mu r. And when you rearrange it and make a substitution, you'd have mv squared over r is equal to mu by mg, and you get mu is equal to v squared over gr. I'd ask you to re-watch that and do it yourselves. If it doesn't make sense, then you can ask me whatever questions you want. Okay, some centripetal force calculations, and this section of the video will go quite quick. So what you need to do is pause the video, The answers are after the questions themselves, and just work them out. Next video. And like I had previously, I'll do the solutions to these in a separate video. Okay, third slide. Moving on, the fourth slide and the fifth one. There we go. So work away on those and I'll give you the solutions later.